Alright, let's look at cube and cube roots. Now let's go first over some definitions. A perfect cube. A perfect cube, kind of like a perfect square, is a number whose cube is a whole number. So basically, 2 to the third power, 2 times 2 times 2 is 8. So my 8 is going to be my perfect cube. Now a cube root is a number that when multiplied by itself, then multiplied by itself again, equals the number under the cube root symbol. And with the cube root symbol, it is a radical symbol, just like right here, with this little 3, telling you that you're taking the cube root rather than the square root. So the cube root of 8 is 2, since 2 times 2 times 2 is 8. Now, we can use these perfect cubes to estimate non-perfect cubes. So let's look at some examples. 4 cubed. Well, we've got 4 times 4 times 4. 4 times 4 is going to be 16, and 16 times 4 is 64. So my answer to 4 cubed would be 64. Now 7 cubed. Again, 7 times 7 times 7. Okay, 7 times 7 is 49, and 49 times 7 is 343. So 343 is going to be my perfect cube. With number 3, we've got a little bit trickier. It's a negative number. Now, if you notice with square roots, if we squared a negative number, it was always positive. It came out positive. But with cube roots, it's a little different. You cube a negative number, and it's going to come out negative. So if we do negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is 25, a positive 25. But then multiply it by your negative 5 again, and you get this negative 125. And that would be your perfect cube. So over here, while we're doing the cube roots, with square roots, you can't take a square root of a negative number because there are no two numbers. If you multiply them by itself, it's actually going to be a negative number because if I do a negative times a negative, it's a positive. Well, with cube roots, since I have 3 times that I'm doing it, I can take the cube root of a negative number. So if I take the cube root of negative 1,728, I actually get negative 12. Because if we do it, negative 12 times negative 12, which is, we learned with perfect squares, is 144. And then you multiply again by negative 12, and that's going to give you negative 1,728. Now let's take the cube root of 729. With that, if you do 9 times 9 times 9, 9 times 9 is 81, then multiply it by 9 again, and you get 729. So my cube root of 729 is going to be 9. And this last one, this cube, oops, I forgot my little 3 here. I'm not doing the square root of 64, I'm doing the cube root of 64. We did the square root of 64, we said that's a perfect square, but it's also a perfect cube. Now, the square root of 64 was 8. 8. Now, with this one, though, it's got to be a number times itself times itself. And if we do that with 8, it's not going to work. So the cube root of 64 is actually 4, because 4 times 4 is 16. Then you got to multiply again by 4, and that gives you 64. Now, notice, unlike my square roots, my cube roots always have only one answer. So they're going to have one root. Also, the answer can be positive or negative, depending on your actual perfect cube or what your radicand is. Alright, estimating cube roots. Now, this is very, very similar to doing the square roots. So not all cube roots are perfect cubes. In these cases, you can use what you know about perfect cubes to estimate what the cube root of a non-perfect cube would be. So with these two examples, I want to determine which two consecutive integers and that means like 1, 2, or -3, -4, that kind of deal. Each cube root falls between. So I've got the cube root of 56. Well, we said one cube root was, or one perfect cube was 64. And another perfect cube right below that would be 27. So the cube root of 27 is going to be a little less than the cube root of 56, which is a little less than the cube root of 64. The cube root of 27 is 3, and the cube root of 64 is 4. So this cube root of 56 is going to be between 3 and 4, some number between that. Now with this one, the cube root of -389, I need to find a perfect cube that's a little smaller, so that's going to be -512. And remember, when you're going negative, it's going away from the 0 on the number line. So I need something smaller than this, and that number would be smaller. It's going to be a little less than our cube root of -389, which is a little less than our cube root of -343. Now our cube root of -512 is -8, and our cube root of -343 is -7. So this cube root is actually going to fall between 8 and 7, and -8 and -7. Now notice these 3 dots that I have right here in a little triangle. You'll see it in some videos in the future. This means therefore. So when I say therefore, the cube root of -389 is between -8 and -7. It's kind of like stating your solution. This is the answer.